Welcome back. I hope you found page 49 in your math workbook and that you ripped it out. We are going to be doing this practice page together. If you look at the top of page 49, it has a place for your name. So that automatically means, remember, name and number. There's not a place for the date, so you don't have to worry about that. And then remember, if there's not a place, we put it up in the right corner. Name and number. Okay, flip back to page 49. If you look at the chart that we're just going to glance through this page really quickly. If you look at this chart, they're just showing you that here in the ones place, look, they've represented their ones as red with the decimal. Because the decimal always goes right after the ones place. You see it right there? The decimal always goes right after. And then they're just showing you the representation that I was trying to explain earlier. But theirs is actually, they've done a really nice job. So you can see that stepping opposite, so starting right here in the middle and taking a step, you have tens that are wholes and tenths that are pieces. Just take another step. Hundreds that are wholes. Hundredths, pieces. Take another step. Thousands that are wholes. Thousandths that are pieces. So then they give a really great explanation of what these would be. I love this when they're dealing with money. Take a look. $1,000, $100, $10, $1, dime, penny, and a tenth of a penny. A piece of a penny. That's a really great explanation for what a place value chart could look like. I love looking at this. And they did the same thing, remember? Anytime you step to the left, you're getting 10 times larger every step. Anytime you step to the right, you're getting 10 times smaller, which is the same as dividing by 10. Okay? This is a great representation for place value. We are going to skip through the rest of page 49, though. Just take a really good look at that and make sure you understand this. Use it for help if you need it as well. Turn to page 50. They are going over all of the word forms that we have learned. Standard form, word form, expanded form, and they've represented it as doing it in decimals or place values. So that's how they would like it. Remember, it's good to get used to different phrases. For example, Ms. Fisher used the phrase using powers of 10. In their situation here, that would be using place values. But we also learned both, so we'll be just fine. Here's what the top of the paper says. Make sure you read it out loud while I read it with you. Represent numbers different ways. In our place value system, numbers can be expressed different ways. I think that's kind of a typo. I think it can be expressed in different ways, but it's fine. Different ways to represent the number 35 and 26 thousandths are shown below. Here's standard form. Love it. So easy. Word form. Read it with me. 35 and 26 thousandths. I hope you left your crayons out. You're not supposed to put those away yet. There's that word and. That must mean there's the decimal separating wholes and pieces. And then they showed us expanded form. They said, what does that 3 really mean? Well, it's in the tens, so it means 30. What does that 5 really mean? Well, it's a 5 in the ones. It means 5. What does the 0 mean? Nothing. What does the 2 mean? It's a 2 in the hundredths place. And what does the 6 mean? It's a 6 in the thousandths place. So that's all we have to do on these problems. I am only going to help you with probably one of them. We're not going to do, actually we are. Let's do the check for understanding right now. This is a pretty cool one. It says draw a place value chart and show the number 55.555. We're not going to do that part. But we are going to answer the next part. Circle the digit in this number that has a value of 5 times 100. So what they want, I want you to find yellow. What they want is for you to circle or highlight which of these 5s has a value of a 5 in the hundredths or 500ths. Think it through, pause the video, and come back with your answer. You should have highlighted the middle 5 after the decimal. It's this one. I will circle it and highlight it. It's that one. It's not the first one. That's in the tens, then ones, then tenths, and there's hundredths. So a 5 in the hundredths is 5 times a hundredth. I love that. Easy. Okay, I'm only going to do one of these with you, but it is your responsibility to get all of them done. And then you can turn this into the math basket or hang, if you're at home, you can hang on to it until you come to class next. But otherwise, this needs to go in the math basket, and then you can begin your assignment. Let's just begin with, oh man, I don't know. Let's begin with let's do number 2. 8 and 305 thousandths. So they gave it to me in word form. They want me to write it in standard form. That's pretty easy. I want you to box the word "and" every time you see it, because that's going to be important to know there's a decimal there. 8 and. So that looks like this. 8 and. 305. Write 305. And make sure it ends in the thousandths. It did. 8.305. Next, they want me to take it expanded form and use decimals. So I can use my journal expanded form using decimals. Would look like this. In their situation, yeah, they did it. That's what expanded form meant to them in decimals. If they want it in place values, they're pulling each digit. So I think this would help. If up here, if expanded form, you just say that this is expanded form. And for place values, don't worry about the word decimals. For place values, we called this one using powers of 10. Okay? That way it won't confuse you. All right. So expanded form using decimals. That is the red part of your journal, so I hope you didn't put that away. All it is saying, what does that 4 really mean? So here we go. What does that 8 really mean? It stands for just 8, because it's in the ones place. Keep going. Add it. What does that 3 really mean? In decimals, 3/10. So it looks like 0.3, because that means 3/10. Keep going. Add it. What does the 0 really mean? Nothing. What does the 5 mean? A 5 in the thousandths. So it has to look like this. That's your answer. And now expanded form, in their situation, they called it using place values. We're calling it using powers of 10, or the purple one. And they look like they like it in fractions. So we'll go with this top one. You just pull the digit and multiply it by the place value. So pull the digit 8. Remember, this is the one where you use parentheses. 8 times 1, because it's in the ones place, plus 3 times a tenth, 1/10, because it's in the tenths, plus another parentheses. Do you do anything with 0? Nope. 5. 5 times 1,000. That is how you do number 2. You just go with what they've given you. It should be pretty basic. Another good one for us to do might be, okay, I'll help you with number 4. Number 4. Okay, they want it in standard form. Awesome. They've given it to me in the powers of 10, the purple way. So all I have to do is just remember, what does this mean? 4 in the 10,000s place? Okay, let's start with a 4. Then a 2 in the 1,000s place. So those are right next to each other. Then a 3 in the 10s. Uh-oh. It means I went from 10,000s to 1,000s to 10. Let's just take a look at this. I went from 10,000s, which would be over here, to thousands, to 1, to tens, sorry. 10,000s to thousands to tens. I skipped over a place value. What do we put in that place value if we've skipped over it? A 0. So I have a 4 in the 10,000s, a 2 in the 1,000s, a 0 in the hundreds. I don't have any in the hundreds. A 3 in the tens, and a 5 in the ones. And then I know that's where my decimal is, because it always comes after the ones. So now I look at that and decide, where should the comma have been? Oh, it's this. 42,035 and Here I go. The next place over is the tenths. Do I have tenths? Yes. A 2 in the tenths. Okay. The next place over would be hundredths. Oh, they went to thousandths. So that means there's another 0 in there in the hundredths. That's funny. There wasn't 100 or 100th. They skipped both of those. And then I have a 2 in the thousandths place. So it should look like that. That number is read 42,035 and 202 thousandths. Okay, let's write that out in word form. 42,000. Don't forget to put the comma if there's a comma in the number. 42,035 and now I'm doing the pieces. 202 what place value did it end in? Thousandths. Got it. Now I put it in expanded form, or in this situation, it's just what does it stand for? So it's pretty easy. What does that 4 stand for? Well, you can just multiply these. 4 times 10,000, it stands for 40,000. Plus, a 2 in the thousand stands for 2,000. Plus, 3 times 10, 30. Plus, 5 times 1, 5. Plus, this is where it gets tricky. A 2 in the tenths place, what does that really mean? Or you can look at it as this number. Oh, it just means 2 tenths. And they want it in decimals. So plus 2 tenths would look like this. Right? Because there's 2 tenths. And I got one more. I don't have hundredths. I have thousandths, but it's a 2 again. So it's 0 point. And where do I put the 2? Not there, because that's tenths. Not in the hundredths, but right here in the thousandths. So it looks like 0.2 plus 0.002. And that's how you finish that one. So on your own, you need to finish numbers 1 and 3. Then you can turn in the math practice page into the math basket. When you begin your math assignment, it looks like this. The homework side. Write a decimal number for each word name. So you're writing standard form. You can do this. It's so easy. Standard form. Take a look at what you're doing down here. Write each amount as a decimal number. This is on numbers 6 through 21. I know there's a lot of problems, but they're going to go so fast. It's so easy. How do you write 602 thousandths as a decimal? Well, there's not any whole numbers, so it's a 0. 602. Make sure it ended in the thousandths, and it did. Okay, there's going to be ones where there are whole numbers, and that would be a mixed number. There are lots of these on here that you can see. Like, let's take a look at number 15. How would you write 63 and 6 and 7 tenths? Well, there is a whole number. So 63 and the decimal. You put a 7 in the tenths place. That's actually pretty easy. Just like that. Let's try another one that might not be quite so easy, like number 17. 29 and, so that means I've got a decimal. Whole numbers, well, you're going to have decimals, sorry, on all of these. I meant to say, that means you have whole numbers. 29 and 4, so should I just put a 4 here and be quick? No, that would be 4 tenths. I need a 4 in the thousandths place. So I've got to put it all the way at the end there. 3 places over, 0.004. That's how you do those problems. Number 22 and 23. One of these things is not like the other. Circle it, then you can tell your brother or your mother. Okay, so take a look. Which one of these is not equivalent? Not equivalent. So it doesn't mean the same thing. 2.6, 2.60, 2.06, or 2.600. Remember, Ms. Fisher has taught you that you can have as many zeros at the end of a decimal if you want. As many as you want. I could throw tons of zeros on the end of this. Well, just to be fair, let's make sure all of them have 3 digits after the decimal. That one only has 1. So I'm going to add zeros. This one only has 2. So I'm going to add a 0 so that it has 3. Now it has 3. This one has 3. This one still only has 2. Oh, now it has 3. And this one has 3. So it says 2.600, 2.600, 2.060, 2.600. So which one of those is not equivalent? 2.06. So that is how you should do this. You should start with the ones place and just immediately start comparing, or you can add zeros like I did to find out which one is not equivalent. Let me give you an example on number 23 of how to do it a little bit faster. They all have a 4 in the ones, so they're all equal so far. Move to the tenths. This one has a 0. That one has a 0. That one has a 7. That one has a 0. Oh, 4.0, 4.7, 4.0, 4.0. So I already know that that is the one not equivalent. See, it can be pretty quick. Man, I'm just helping you with a whole bunch. I think these ones are so fun. What it makes you do on number 26 and 27 is write 3 decimals that are equivalent. So you can use their examples, see how, and just change the numbers. Change, instead of having it be 2.6, you could have it be 4.9, or your favorite numbers, 5.5. But you would just make them look like the text that's on here that are equivalent. So I'm going to do them as an example, but you can't copy mine. I love the number 5. So I'm going to do 5 point, and we'll do sevens. 5.7. The next one I'm going to give, I'll just copy this one. 5.70. Those are equivalent so far. This one would not be equivalent, so I'm not going to do an example like that, but I'll do it like this. 5.700. Those are all equivalent because if I took off all the zeros at the end, they'd all say 5.7. Pretty cool. Maybe I'll circle those so that they look separated. Don't copy my digits, but you can copy that pattern if you want. And then on number 27, it says to go back to number 26, and now you have to write those as fractions. Don't panic. They all have a whole number, and then I just write it as fractions. So the first one would be 5 and 7/10. My second one would be 5 and 70 hundredths. And my third one would be 5 and 700 thousandths. All of those, these two right here, simplify, if you cover up the zeros, simplify to 5 and 7/10. Pretty cool. That's because it's 5.7, which is 5 and 7/10. So the homework side, super easy. Super easy. When you get to the remembering side, they've stacked them up for you, which is nice, but they are fractions with unlike denominators. Unlike denominators. It's going to take you a little bit of time to do that, but you can do it. I know you can. Number 5 and number 6, you are going to have to do these. Estimating and then finding the actual difference or the actual sum. Let's quickly go over again how to do the estimating. And then you're going to be just fine on 7, 8, 9, and 10. You do not have to do stretch thinking. But let's take a look again at 5 and 6. It wants you to round to the nearest whole number. So easy. 15 and 5/6. Is that closer to 15 or 16? I'll just quickly show you on this one. If I have a table and 15's over here and 16's over there, because that's the nearest whole number, 15 and then 16, you always put that number and then the next number up, remember? And then you have to divide it into sixths. So right in the middle would be 3/6, which means 5/6 would be maybe about right there. So is it closer to 15 or 16? 16. So I always just write it like off to the side. And then 2 and 1/5. So if I were to draw that table, who would be over here? 2. And the next number up, which would be 3. And splitting it into fifths, what's half of 5? Oh, it would be 2.5 over 5. And I only have 1. So it'd be like right there. So it'd be closer to 2. So my estimate is 16 minus 2, which is 14. And now I actually have to go back and do the subtraction, the real math, changing the denominators and everything to find the difference. So you have to do that. And you'll also have to find the estimate and the sum, which means you're adding here, on number 6. Good luck to you. Thanks for hanging in there. Don't forget to first finish numbers 1 and 3. Put this in the math basket, and then you can work on your assignment.